Hey, so we are back again with another LeetCode problem. So this is very famous fruit into baskets. I'm sure you guys have heard about it. So we'll be trying this. I've already tried this. Uh, I have solved this in the brute force approach before, as you can see here, and also I have think also solved it uh, using the best approach that I could, but it was before I knew sliding window. Now I know sliding window, and I'm just will try to solve it. So recently, yesterday I solved this using the brute force approach, and then when I tried to solve it with the sliding window, I couldn't. So I thought I would give it a stop there, and I would try it the next day. So today I'm trying it, and I don't know actually if I'd be able to solve this problem, but I would give it a try. So yeah, we'll just time it also. So this time we'll time it because already solved it. So I kind of forgot what the question stated because I didn't give myself enough time yesterday. I think so today we'll give 20 minutes, exactly 20 minutes. If we'll be able to do it, I'll most probably post this, or else I don't know, I'll post this if the intuition to the problem is perfect. I'm not feeling actually well. I have a little bit headache, but I'll still try to do it because consistency matters. So here we go. We'll just read the question. So you are visiting a farm that has a single row of fruit trees arranged from left to right. Okay. The trees are represented by an integer array fruits, where fruits I is the type of fruit the ith tree produces. So these are the trees, right? And so basically, fruits at the index 0, this is uh, type 1 tree, uh, and there is type 2 tree, and there is type 1 tree again, right? So you want to collect as much fruit as possible. Sorry guys, 1 minute. Yeah. So you want to collect as much fruit as possible. However, the owner has some strict rules that you must follow. You only have two baskets, and each basket can hold only a single type of fruit. There is no limit on the amount of fruit each basket can hold. Okay. Yeah, so we have two baskets. So most most we can have two numbers, right? So these are basically numbers, right? So in an array we have some numbers like mota mota. If we want to like break down this problem, we have some numbers in the problem, and we want to try and find the two numbers that are repeating consecutively, right? uh, I think I've understood this problem well. You have only two baskets, and each basket can only hold a single type of fruit. There is no limit on the amount of fruit each basket can hold. Okay. Starting from any tree of your choice, you must pick exactly one fruit from every tree. So you can start from anywhere in this. While moving to the right, the picked fruit must fit it fit in one of your baskets. Once you reach a tree with fruit that cannot fit in your basket, you must stop. Right. So basically, start from any index, and you will have to stop at a position where you cannot. Uh, your basket is basically full with the. You cannot mix another. You basically have another fruit that is not matching your fruit. You have uh, your two fruits that you have already picked, right? So for example, there is 0 and 1, and then whenever you encounter 2, you cannot put it in the basket. So the maximum element out of this is 2, right? So given the integer of array fruits, return the maximum number of fruits you can pick. So maximum number of fruits you can pick. Number of fruits you can pick. So maximum length you can pick, right? So maximum number, the longest, right? So basically, the if we try to frame this question as a simple question, we have to find two numbers that has the maximum amount of length, right? So the maximum subarray length by uh, two consecutive same numbers. That is the thing we are trying to find. if I'm right about it. So 1 2 3 4, and this is 3 again. Yes, that is what we are trying to find. And the brute force approach that I used to solve this problem was, uh dude, I forgot about it. uh I think, yeah. The thing is that I have solved it without watching anything, so I cannot remember the specific problem, but I think I would be able to find out the brute force solution to this problem also. So I would try to think about it. Okay, so we have already, I think, we have 5 minutes into the video, if I'm not wrong. Yeah, we are 5 minutes into the video, so I think I'll give uh 25, how many minutes? Yeah, 15 minutes we would. Yeah, so let's start it. Yeah. So if we try to find out, so the very brute force way to find out this is like generating all the sub arrays, right? So uh, one thing is for sure, there is consecutive elements, right? So you have to find the consecutive, the length of the maximum consecutive subarray which has only two elements, right? That is the that is the basic question that they are trying to ask. And first way is to generate all the subarrays. How we can do that is using two for loops. The first for loop would go from I 0 to n, and the second for loop will go from j to n, sorry, I to n. And that is how it will start. And how can we figure out that the two, yeah, so it is very easy. I think if we try to find out, so normally if I want to write about it, so the normal brute force approach to this would be a brute force, right? The brute force approach would be just for int I to j, I to n, where n is the basically the length of the fruits array, and there would be a for int j equals j, that is starting from 0, and j that will be going till n and j plus plus. Simple. And this will go on, and we'll try to figure out every time whether the first element that we have got and the second element that we have got, uh, until unless, yeah, so this is the thing that they told us, right? Once you reach a tree with fruit that cannot fit in your basket, you must stop. So let's say for this one we start from 1, and for here we will just have one basket. So int basket equals to the simple thing that I, right? That is the thing. uh Sorry, it isn't the right thing that I did there. uh it'll be, yeah, this, and this will be fruits I, that is the thing here. And uh this is basket 1, and we'll have the same thing and just basket 2, and it will be -1, right? Because one thing is for sure, in this fruit length there is only positive elements. As you can see, it can start from 0, and it can the fruits I can be less, uh, less, uh, as much as 0. It cannot go beyond that, right? It cannot go lesser than that. So that is the thing that we want to do here. So here there can be three conditions here, basically, what I can understand. So the first length, so it is not 0, it is I basically. Yeah. So the first thing that can happen here is like mostly it can be the first element. So if so we can do, what we can do is int fruit equals to uh, fruits. I'm just writing the brute force solution because it is impossible to go to any solution, because you need to figure out the brute force solution first, and then you kind of get to understand the other concepts, right? I don't want to get into the sliding window concept before that. So we got the fruits j, and we want to have check first. So at first it can be it can be the first, it can be the fruit that is that we have in the first basket, right? So fruit if fruit so first of all, we need to figure out what we want to do. If it is in the first basket or in the second basket, we just continue, right? So we don't care about it. We will only break, we will only stop when we kind of understand that basket 1 has fruit I, and the fruit that we have got now is not the same as it is in basket 1, right? And it is also not same in the basket 2, then only we'll try to stop, right? But there is one thing also, basket 2 is empty. So what we want to do is we want to check if fruit if fruit not equals to basket 1, and also fruit, or is it, or no, sorry, and fruit not equals to basket 2, then we check one condition, that fruit if basket 2 equals to -1, then we know for sure that then we know for sure that basket 2 should have fruit, because we are just storing, because it is empty, right? So we store that fruit into the basket, and next time whenever we get the same element, right? So first of all, the basket 1 will store 2, and then there will be 3, and whenever there will be 3, we'll try to check, and this condition will be true, and this condition will also be true. So basket 2 is empty, and we want to store another fruit in that, so we'll store fruit in that particular basket 2. And whenever there will be repeating elements, like if it was 3 again, then it would also store that into that basket. So else, if it is not the case, if basket 2 is not -1, then there is already a fruit, and we have encountered a fruit that we cannot store in the basket. So at that particular time, what we want to do is we'll just break out of here. So it will be break, and so we'll just also run it so that we'll be able to check it. So I think here until this line it is fine. So it will be it is not break. So every time we'll check the max. So what we are trying to return is the maximum number of fruits. So here we'll have first of all we'll have the nth thing. So int n equals to fruits dot length, and also we'll have to max len equals to 0, right? And yeah, maximum number of fruits. So maximum fruits, let's say fruits, max fruits. And what you want to do is like max fruits equals to math dot max max fruits, and the basic thing is j minus I plus 1. Basically the length we have till now. So let's say it is starting from here, and we have got this length, right? So it is 0 1 and 2 3 4. So 4 minus 1, that is 3, plus 1. Plus 1 would add one element because it is starting from the 0th index. It is very easy to understand. So that is what we are trying to do, and we'll get something here, that is the max fruits, and I think it is done. We don't want to do anything else. We'll just return max fruits, and I think it will work. Now the thing is, 10 to the power 5 is the expected time complexity. So we can so 10 to the power 5 is the highest, it is the maximum number of the maximum number of the length that can that this array can have. And according to the compilers that we have in this according to the judge that we have, that the compilers that we have in this LeetCode platforms, we cannot go beyond 10 to the power, so 10 to the, we cannot go beyond 10 to the power 10, or we should always try to have a solution that is basically that consumes time less than 10 to the power 10, or less than that. 10 to the power 9 would be much, 10 to the less than 10 to the power 9 or 8, that would be much better. So now our solution is big O of n square. because we are running from this loop, and this loop is again running. So big of n square is the expected time complexity for a case, and it would mostly give a TLE, because the expected time complexity for the longest array would be 10 to the power 10, and that is, yeah, so you can see, oh my god, so yeah, that is a problem, right? So what we want to do here is we want to have a sliding window concept. So we don't have much time here, but I think I would give me some extra time for that, because I've written the brute force approach again. So let's try to think how we can have this same solution, how we can uh, so the main thing is this, right? The main thing is this. So what we can do is we can try to figure out some two pointer approach, because whenever there is subarray, whenever there is subarray or substring problems, and there is a maximum length problem, we tend to go towards sliding window. That is how you figure out that it is a sliding window problem. And I think I would try to get something here. Uh, so guessing from here, I think what we can do here is, like, let's say there is left and right pointer here, and whenever we have left and right pointer, so the problem is how to understand how to understand from which position we can give the left, from which position, from like which number should be stored into the basket 1 or which number should be stored in the basket 2. That we need to figure out. That was the problem that I was having before, in the sliding window problem. So that is why I was getting stuck into it. So 1 2 3 2 2, that is the thing. And let's say there is left and right pointer, and the 1 is stored into the basket 1. Then we move to 2, and it is stored in the basket 2. Now we try to store the 3, and when we start to try to store the 3, we basically have to remove something. And how to understand, like, how to get it, that what we need to remove from here. Obviously the last element that we entered was 1. We need to remove 1, right? And when we remove 1, we remove from basket 1, because left is storing this 1. So I think that is how you understand, wherever the left pointer is standing at, we'll just remove that element from the we'll just remove that element. So let's say left pointer is pointing to this. So if basket 1 has 1, then we'll remove it from basket 1 or basket 2. Or if it is not there in basket 1, it will be removed from the basket 2. Okay. Let's check it whether it is working or not. So first of all, we'll store it in the basket 1, it will be basket 2, and then again 3 will be stored. So when we'll encounter 3, we'll know for sure that we need to move the left pointer again. So left pointer will be gone to 2, and the basket 1 will be empty, right? So whenever we got a basket empty, we'll fill it with 3. So basket 1 now has 3, and basket 2 now has 2. So again 2 will be encountered, it will be stored, 2 will be encountered, it will be stored, and then it is the end. And we don't need to continue, because the maximum element that we got is like 4. Why do we need to continue then? Um, the right reach the longest element, right? We cannot. So it doesn't make sense. It doesn't make sense to like minimize it, like move the left pointer to the right, because it will just shrink the length. So we don't want that. We want to get the maximum length. So the condition will be while r or the right pointer reaches n. So for a moment, if we just comment it out, I'm sorry, I'll try to. So there is a call. My mother is calling, so I'll just answer it. Sorry guys for the intermission. I think uh yeah, so where we yeah, so we figure out the brute force approach, right? And what we are trying to do here is like generate a sliding window concept. So if we if we did this, it was fine, but we need to have something. Let's say we got something like this, and again 2 and 1 1 and 0, and let's say this is the longest thing that we can have, and we'll check on this longest thing that I can see here, 3. If we start from 3 to 1 1, so the longest thing is I think this 4. Yeah, so that is 6 elements. Is there anything else? I'm not sure. If we start from 4, no. If we start from 2, that is the 4. This is 3. Okay. If we start from here, no. So I think yeah. So the longest element can the longest substring that we can find sub array sub array that we can find is like this with 6 elements. And let's see whether our algorithm is working fine with it. So let's say we have basket 1, and there is basket 2, and first there is 2 and there is 3, and it breaks, right? And the left and right pointer moves, right? So left, let's say left pointer is there and right pointer is there. It is first 0 and then 1. So it is also 0, sorry. So when we encounter r with 0, we'll first it will be -1, so it will store this 2 into this, and then r moves, and we check whether it is same to the basket 1 or basket 2, and we also check that if it is same as the basket 1, it continues, or if it is not equal to the basket 2 and the basket 2 is -1, then we store 3. Very good. Then we'll go to 4, and we encounter 4, and also see that L is at 0, and that 0 position is 2, and also the basket 1 contains 2, so we remove 2 from here and it will be -1. And the 4 that we'll have right now, it will be checked again. uh, so the basket will be checked again, so basket 1 has -1, so it will be 4. The maximum element that we got is like the maximum length that we have got is like 2, so max len equals to 2. I'm not sure this is the best idea that I can think of, but I think I can. Let's see what I can do here. So we also don't have much time here. Let's give 10 minutes. If we can figure out it in 10 minutes, then it is good, because I have also other things to do. We cannot do much things today. Okay, so the left pointer is at 1 right now, with 3 as the basket 2 and basket 1 will be 4, right? So yeah, uh, to see whether I can have anything else, because every time we try to figure out which basket has which thing, that is a time consuming thing. Every time we have to check, is there any other way? Oh, let's see if if it is fine to, if the algorithm works fine. So uh, max length equals to 2, and the L is at 1 and R is at 3, I guess, right? Or 2, 0, 1, 2. L is in 1, yeah. So R is 2, and then R is 3, and R is 4, and then 5. And whenever it hits 5, we also check, and we kind of got that, yeah. So 5 and then 6, this is the maximum thing, this is the maximum that we can go, and 6 minus 1 is 5, and 5 plus 1 is 6. So the maximum length we can find is 6, because after that there is 2, and whenever the R is 2, we try to check where is L, and L is at one position, and that one position contains 3. Basket 2 has 3, so we move it to -1, and R position has 2, so we move the thing to 2. Okay, so one thing for sure is that whichever basket we are eliminating, we are storing the new element there. So that is one thing. So whichever, I don't know if it is, we'll write it. Whichever basket is -1, we store the new element there. Whichever basket we we put in -1, in whichever basket we put in -1, we put -1, we store the new element there. I don't know if it is, if this would help me somewhere, but I think it would. So okay, the R is 6 here, and I think 7 here, and uh, basket 1 is 4 again. So R will move to 1, and we right. So whenever R moves, okay, there is a problem here. So when R moves to 7, basket 2 gets to 2 and basket 1 gets to 4, right? And we also eliminate, so the 3 gets eliminated from here, so it will be like 2, right? And whenever it gets eliminated, we also have this thing that after being eliminated, this array would be having all elements, that is, so there is a problem. So the problem is, there is still a 3 here, and whenever we reach here, the maximum length that is there is also 6, which is not right. This is not a valid sequence that we can have. There is a problem. This approach wouldn't be the same, this approach wouldn't work. I think a better approach would be, I think we need to store the, we need to use the hash map here, because we need to take care of the uh, we need to also take care of the indexes, right? So if we use hash map here, we need to also figure out, yeah, so we need to use a hash map. Let's say there is a hash map we are using and not a basket 1 and basket 2. Let's say we use a hash map, and we have a hash map, and we at max we can only have 2 elements there. So first there is 2, which is mapped to 0, and there is 3, which is mapped to 1. Did we do this? should it should it is it a good way? I think we need to figure out the last position where you need to start, where you need to start from. um what I mean by that is, like, for this array, particular array, so whenever we find a thing, whenever we found 2, we would have to jump to 4, right? Because before that, if we jump to 3 here, it is not a good decision, right? We have to jump to 4. And how do you know that we have to jump to 4? That is the thing. That is the thing. So uh, so let's say, so what position is this? 0, 1, 2, 3, 4, 5, 6. So 0, 3 is 6. Let's say 3 is 6 and 4 is 7, I guess. Yeah, so so 4 is more closer to 7, right? The left and right pointer, the right, I figured out the right pointer. The right pointer moves until unless you get the right hand pointers move until unless you get a new element that is not in the basket. The left pointer is the main problem here, because the left pointer needs to move very trickily. It is a trick, right? So we need to very clearly understand why the left pointer needs to move. So the left pointer will only try to move when there is only one element, when there is no element in the between that can uh, lead to lead to a third element, right? So let's say this is the thing that we have, this is the longest thing that we can have, and after that we encounter a 2, right? Sorry, so this is the yeah, so we encounter a 2 here. So at that particular time we need to check in the hash map that is there in is like, have we got anything? We have to, I cannot understand how we can do that. That is a very tricky way. How will I check whether, okay, so is there a 2? So we'll check by that. So is there a contains key? We'll check by the contains key. Is there a 2? There isn't a 2. and the and the left pointer is pointing to 3, right? And also if we remove the 3, it will move to 4. And if we move to 4 and if we remove 3, we cannot remove 3 because we don't know how much 3's are there here. Are we getting that? So we cannot actually remove 3. We can actually. So if we start from here, if we start from this 3 position, if we are checking, if we are replacing the uh, if we are deleting the left pointer's fruit, then it wouldn't work also, because the last element is there as 4. This is very tricky. I cannot understand how can I solve this. The only thing that I can get into my mind is the brute force approach. Is there any way I can figure this out? We'll just have how much time is it? There is already 35 minutes, so we cannot have much more than that. I think I cannot solve this. I have to see the solution. But last, I think I'll give my some 2 3 4 minutes to just try to understand if something comes up in my mind. I'm very wrong about using a hash map here. Hash map won't work, I think, because we don't know actually, we don't know actually which position to swap the numbers from. The left pointer wouldn't work like that. So one is shrinking and one is like getting elements into the sliding window, right? Once this the main is like the right pointer will always try to get more elements, and the shrinking is the actual thing that we need to figure out here. The shrinking thing would only work. How can it work? So here we know there is how many elements? How many elements are there? There is 6 elements is there, right? And there are 4 elements here, and there are 6. Yeah. So the left pointer will be here, and the right pointer will be here. If we have this, that we store the occurrences, like 3 is 2 and 4 is 4. If we do like this, and we move the left pointer until unless 3 becomes 0 or 4 becomes 0, until we cancel out one element just to have another element, I think that would work. What I'm trying to say is, like, we'll just shrink it. So we'll shrink it by 1, and 3 goes down to 1, and then 4 goes down to, until unless we have 1 0 here, we'll just shrink. Okay, we'll just shrink. Also, how can we understand that it has become 0? We'll understand by shrinking every time, and we'll be checking that if it has become 0. Yeah, that will work. So 4 becomes 4 4 becomes 4. Let's say it will shrink down to, like, uh let's say it will shrink down to 4 4 and 4. 3 elements will go, and it will be also 1, and this 3 will be 0, right? Then this 3 will be 0, and we don't have any 0, right? And this 3 will be gone. 3 will be gone, and there is only 1 4, and the left pointer would be pointing to this particular position. And then we can, then as the 3 is 0 now, we can eliminate 3 from here only. So as it is not relevant now, we can eliminate 3. So let's say we eliminate 3, and what we can have here is, like, we can have 2. So it will grow, our right will grow again. It encounters, so 2 will be 1 again. And this is the thing that will happen there. And then it encounters 1, and the left pointer is here, right? The left pointer, as soon as we get left pointers to be 4, we need to go to the right again. And when it goes to the right again, because we have encountered 1 and we cannot enter into this particular thing because the maximum size of the area is 2. I think this is the way. I think this is the way. Can we just code it up? I'll quickly try to code it up. We don't have much time actually. As we figured this out on our own, let's just try to code it up. So we'll have the same thing. So int max fruits and int n, this is the same thing that we'll have. Okay, so we cannot delete this. Let's not delete this part because it is important. We figure this out. We need to try. Yeah, so this is the thing, and there will be L, that will be 0, int R will be 0, and the main condition is R less than N. Now the shrinking thing that we can, okay, so we'll also be using hash map, right? So map first one is number or integer. Sorry, what I am doing. Yeah, so map new hash map. Yeah, again in the map we'll try to check. Now here, when will be the shrinking happening? The shrink will only happen when Yeah, so the shrinking will only happen when we encounter a third element and the key doesn't contain that element. So let's say we encounter a new fruit. Okay, so a fruit will be basically fruits, and let 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 it be f, and fruits are, that is the thing we have. And now we will check uh, if if the map that we have that has size greater than is equals to 2, or most map dot contains key f, if it contains, then we don't have any problem. If it does not contain it, then we have a problem. That means we need to we need to basically delete its occurrence. Is that right? So what we need to do here is like map dot set whatever the f, and also is it the left. Okay, so what we're trying to do, I'm just trying to understand what I'm trying to do here. So if we encounter an element which is int in this particular map, and also the map size is greater than equals size is great size is size is equals to 2, exactly 2, then we know for sure that this element is a new element and we need to move the left pointer and also decrease the occurrences, right? Decrement the occurrences. So what we need to do here is like map dot set whatever we have in the left pointer. So fruits left, we will remove it by 1. So map dot get fruits by map dot get fruits by, sorry, map dot get fruits, uh, sorry, what I'm trying to do here, the left thing, map dot get -1. So what we did here is like we are getting the left element. So let's say we have this element here, and whenever we get 4, we are checking, we are deleting this 2 element because the L is at here. So we are trying to delete the occurrence of 2 from here so that we get the 2 to be 0. Now in the map we have 2 as 0. So we have to check if map dot get left value equals to 0, then we need to remove it, right? Map dot remove, is it remove get there is put, I think this is put. I'm really sorry for the method I've started LeetCode after many days. I think it is remove. We'll see it if it is not remove, but I think, yeah, so remove, and we'll remove the left pointer, sorry. So it is fruits left, and again this is also fruits L. So what we did here is we have successfully, so the shrinking phase will continue until unless we have, this will be a while loop basically. The shrinking phase will continue until we have less than 2 elements, so L plus plus, and it will continue. And every time what we try to do is like we add one element to the hash map. So map contains map dot set or put right element, so that is fruits right element map dot get or default uh, fruits are fruits are 0 plus 1. So that is how we add element, and the right will also increment, and also we'll have to do max fruits check. So max fruits will be max fruits equals to math.max. This is the main thing that we need to do, fruits and right minus l plus 1. Yeah, so that is it. Lastly, we need to return max fruits. I think this is done. I think if I have not done anything wrong in this particular section, I'm good to go, but I'm sure I've done something wrong here. I think that map.remove will just have a problem here. Is there any issue with my net? Oh my god, what is happening? Okay, uh, something is that return value matter is object map.get. Object is null at line. What is null? How can it be null? Okay, this will be root cell. Oh my god. Yeah, so if the fruit value if the left value is 0, we remove it. We can just be like, we can just be if this is if, yeah. Oh, it did run. Okay, we got the solution. Is there any fruit right here? I cannot believe I did it. It was very clever, I think. The solution, I think. Why is it so slow? Is my solution slow? It is not. It will take, it will just take big of n. It's sorry guys, I don't know what is happening. I think there is something wrong with my internet, or the judge is just problem. Oh my god, there is a problem guys. I don't know if it is because this is the slowest solution possible. Oh my god, what is wrong with it? But what is wrong with it? I'm the last person. What is wrong with it? But did I do something wrong? uh oh my god, I'm the last person. This is the slowest solution I can think of. Oh, what? Oh my god, I did something wrong here, I guess. Dot get fruit cell minus 1. Should I have done something? Is the map, is it because of the map that we are trying to add or remove every time? But map doesn't, the every operation that we do in map is big of 1. It shouldn't be costing us that much of, I don't know if it is my, I don't think it is the, what? I cannot believe it. It's big of n, dude. How can it be so slow that I am the last person? See, it is big of n. What is the problem with this? Okay, I will watch a solution. We did it, guys. We did it. I was thinking I was not able to. Wouldn't be able to do it, but we did it. I would upload this. I would upload this. Uh, okay, I'll watch the solution of how this can be. Mostly, it is a better solution, I guess. I think I'll be seeing the optimal solution also, and I'll be doing it and posting it. Not posting it. I mean, doing it in the code and I'll be submitting it also. Thank you for watching this video, guys. Leave a like if you like the video. I wanted to I will try and mostly post more videos of how I think, because this is the time I'm trying to improve my tuition. I think this is very huge for me, that how I figure this out, because I was very, it was very hard for me to get this. It was very hard for me before to get the map logic. It was very I think it was very tricky for me to understand the map logic, but I think I did well. I get blocked after a certain period of time. Uh, I couldn't find any other solution, but this time I think I did good. This is the turning point, guys. Uh, Thank you. Peace.